Perfect. So there's our slides. As you can see, Andy and I are not running from bulls, so we're happy and here to present. So yeah, who are we? We work at Fairwinds, and Fairwinds, we are basically like the Kubernetes company, kind of to summarize it or in a short sentence. And we do a lot of stuff. Like we manage clusters for clients. We work with, maybe upwards of 100 clusters or so. We do a lot of consulting projects on how to advise people to use Kubernetes, where the pain points might be, how they can migrate to it, a lot of stuff like that. We also have a SaaS offering, Insights. It brings visibility and recommendations to issues around governance, security, configuration, cost, and a whole bunch of other things. And so, yeah, in a nutshell, we basically help with Kubernetes. If you have Kubernetes problems, we are here to help. One other thing we do, which kind of cues us into this talk, is we have a lot of open source tools that we've written. And we've written these from seeing problems through, all of our experience in Kubernetes. And as these come up regularly, we try and put them in open source to, basically solve those as easily as we can. And so from the talk, how to optimize things with security and using Polaris and Goldilocks, Kubernetes is really hard. And these are two tools that we have written to make it a lot easier to figure out how to optimize workloads and how to secure them. And so this comes to the introduction piece where, yeah, I'm Rachel Sweeney. I work with our Insight software as a service, getting in the nitty gritty technical stuff. And this is Andy. I'll let you introduce yourself, Andy.
Hey everybody, I'm Andy, CTO of Fairwinds and author and maintainer of several of our open source projects. So I just love everything open source and everything Kubernetes.
Awesome. Shall we get into it?
Sure. So we're going to talk about two different tools today, and I'll just give a quick high-level overview. The first tool we're going to talk about today is Polaris. Helps you identify different configuration errors in your workloads. It supports a bunch of checks pre-built in, and then you can extend it with custom checks using JSON schema. And then it has a dashboard and a mission controller and a CLI. So we'll see actually all three of those there in a minute and during the demo. So I'm not going to talk about those now. And then the other tool, which is near and dear to me because I love talking about resource requests and limits, is Goldilocks. So over the years of running clusters for our customers, we constantly told them, set your resource requests and limits, set your resource requests and limits. And they'd come back to us and say, well, how do you set your resource requests and limits? And we said, well, let us go look at your Datadog dashboards for an hour and come back with a recommendation. And that process is a little bit not ideal, not super easy. And so, and at the time, I wanted to learn Go. And so I came up with the idea for Goldilocks and utilized the vertical pod autoscaler as a recommendation engine and provided a nice dashboard for our clients to be able to see recommendations on their resource requests and limits. So from there, I think we can just jump straight into demos.
Yeah, I'll add real quick that, when I first started setting up Kubernetes at my previous job, I was in charge of getting the cluster set up, figuring everything out, and I kind of stumbled upon Polaris and Goldilocks, and they were so huge in me learning how to use Kubernetes effectively. And there's so many unknowns that we just don't know about. And yeah, what I really love about these tools and get excited about is how it kind of brings that to light and shows us how to configure everything. So yeah, let's dive in. I'm excited.
All right, cool. So just a little bit about the setup. We have a multi-tiered application. It's called Yelb. It's from someone else's GitHub repo that I borrowed and wrote Kubernetes manifests for. And so it's got a front end, a back end, a Redis cache database. And I've been generating load against this for quite a while now. Just been sitting there hammering the thing and clicking on the buttons with the script. And we have Goldilocks and Polaris already installed in the cluster. I'll talk briefly about how they're installed. But that's kind of the quick setup. So I will share my screen here and we can kick over to that. Thank you. All right, so this is the demo app. Relatively straightforward. Just got 4 buttons. We click on it. It stores the information in a database. And this is all defined in a bunch of YAML. So I didn't write a Helm chart or anything fancy like that. I just did some YAML manifests. And so I have this directory that deploys my application, and I want to know, where do I potentially have security misconfigurations? Where do I potentially have different things that I can optimize about this? So the first tool I'm going to use is Polaris. And I have Polaris installed as a CLI, and I'm going to audit the directory where I have my YAML. And I just want to look at it on the screen right now. So I'm going to do a format pretty, and we're going to run that. And it's going to run a bunch of different checks across the different manifests in here. And they're going to be, some of them are going to be successful. Some of them are going to fail. Some of them are going to be warnings. All of the warning levels and everything are configurable via a config file. So I can see I'm passing quite a few things. My deployment for my DB has resource requests and limits set. I don't have a readiness probe. I don't have a seccomp profile set up, and I don't have a liveness probe, and I haven't specifically said I want to read only file systems. So we're going to get warnings on all of those things. And I am going to also only show failed tests. So there's a few different output options where we can just see, is it warning, is it danger, and different things like that. So this is the quickest, easiest way to use Polaris. Just throw the CLI onto your computer and run it against your code. The next thing that Polaris can do is provide you with a dashboard. So if we look in the Polaris namespace, we're going to see that we have a couple of pods running. So we have a dashboard and a webhook. And I've set up an ingress and stuff like that to point to it. This is all installed via a Helm chart. So we're going to go over here to Polaris at our URL. And we're going to see an overview of what I just saw on the CLI on a dashboard here. So I can take a look at this and see, we get a grade based on how many dangerous checks, warning checks, and passing checks we have. And we're going to see this across our entire cluster. So we see this for every single namespace here, every single workload that Polaris wants to look at. And that's probably way more information than I want right now. So I'm going to go and filter this down to just my app namespace here so that I can take a look at it.
So yeah, if you're like me, when I first got into Kubernetes a few years ago, I saw all these checks and some were warning, some were failed. And I was like, I have no idea what this is, but like it's failing. Like I should probably care about this, right? And so, yeah, it's a great thing to just look at and figure out what it is and if it actually applies to me. Because some of these things might not actually, it might be a check that's failing, but the way this app is configured, it might have to use root permissions, or it might need to, maybe not root permissions, but it might need access to the host path, for example. And so, yeah, it's just a great way to quickly look and see, like, why should I care about CPU limits? Why would that be important to set up, Andy?
That's a great question. And so from Polaris dashboard, we have a nice little link here. It says, it's just a question mark. CPU limits should be set. I'm going to click that, and it's going to take me out to the docs for Polaris. And we're going to have some information here about why we might want to set things. So I can talk all day about why we should or should not set CPU requests and limits, specifically requests. But you can go to the docs, and we're going to link you out to some nice places where you can read more about this and see why these different checks are important. All right. So am I missing anything here? We have the links out. We have the different configurable levels. All of these are configured via a config file as well. So we can say, maybe in my clusters, I'm much more worried about CPU requests and limits, and I want those to be danger level checks versus warning level checks, which I've actually done here. So we're going to talk a little bit more about a few of these. So liveness and readiness probes are by default required. Those are super important for the reliability of your applications, just to make sure that they're not receiving traffic when they shouldn't, and so that Kubernetes knows when to shut down an app that's maybe not performing correctly. And CPU requests and limits affect, how we schedule apps and where they go, and prevent noisy neighbors and things like that in our cluster. So I see a question in the chat that I'm going to answer real quick because I think is very relevant. Perhaps, as Rachel alluded to, we have an application that needs one of these things. So one of the checks that's set by default is host network should not be configured, which in general is a good recommendation. But maybe there are certain applications like a CNI that needs that, and I want to exempt that from my workload. So we can take a look at our YAML, and Polaris includes an exemption system. So if I look at my Yelp deployment app server, we're going to see a annotation, polaris.fairwinds.com/deployment missing replicas exempt true. Polaris by default expects you to be running more than one replica of your app, but in this case, I'm using a horizontal pod autoscaler, and so it's going to control how my app scales. And so this particular one, I'm not going to worry about the specific replica count on this deployment. I'm going to rely on the HPA to handle that. All right. Feel free to keep those questions coming. I love answering any questions that might come up. So we've seen the dashboard, we've seen the CLI, we've seen some of the checks that are available in Polaris, some of the defaults. We've seen the documentation, which will show you all the different checks we have enabled for security, efficiency, and reliability. And then maybe, we have all of this configured. We're deploying nice, good apps to our cluster. We want to make sure that we're doing that over time and that we don't allow any particular capabilities to be introduced into our cluster. And this is where the admission controller comes in. So I showed you we had two different pods running in our Polaris namespace. One of them was a webhook, one of them was the dashboard. So the admission webhook that gets installed allows us to say, don't allow anything with dangerous failing checks to be deployed to my cluster. And so if you'll remember, I have specified that not setting CPU requests and limits is dangerous in my cluster here. And if we take a look at the Redis server, we'll see that that's actually been disabled. We can probably see that from the CLI, or we can take a look at the Redis YAML here and see that I have removed the resource requests and limits for this. And so I'm going to attempt to deploy that again. And what's going to happen is Polaris is going to come back and tell me, hey, you can't deploy this to this cluster because memory requests aren't set, CPU limits aren't set, CPU requests aren't set, and memory limits aren't set. And like I said, this is all very configurable via a values file with your Helm chart to say, here are the different checks that I want to look at. Here's the different levels I want to specify for those. And by default, anything that is danger level is going to be rejected by the admission controller. All of this is very configurable behavior. You can even disable allowing exemptions. So if you don't want to let people create annotations to exempt them from checks, you can totally do that with Polaris as well. So we're going to edit our deployment here, and we're going to fix our issues with our admission webhook. And we'll go ahead and redeploy that Redis server. And now if we go back to our dashboard, hopefully our C- will start to go up a little bit. All right, we're up to a B.
There we go. One thing I love about that admission controller is, we see a lot of clients that as they, kind of mature in Kubernetes and get better at using it, they decide that they want to fix all of these CPU requests and limits because they want their cluster to auto scale efficiently and, not run into issues where they have to go in and manually do stuff. And so they might spend like a couple months doing that. And then what happens is if they don't have something like an admission controller, they could onboard somebody new who deploys something to the cluster, and suddenly they might not be using, CPU requests and limits again. And so by putting the admission controller in there, it actually forces them to. So once you have it at the state you want it to where the cluster looks the way it should be, then you can start to enforce it. And as you onboard new people, you don't have to worry about them messing up or, as we all do, just deploying things that don't meet our best practices that we have internally. So yeah, it's a really, really cool tool for that.
Definitely. Polaris was created out of, like I said before, running clusters for clients. And the dream was that, we have a series of admission controllers that prevents our customers from deploying anything that might cause disruption to other things in their cluster at any given time. Because 90% of the, and that's a totally made up number, but I would say 90% of the issues that we have in our Kubernetes clusters are not related to Kubernetes itself. They're related to the apps that get deployed on Kubernetes and how they're configured and the different things they're trying to do. So, all right. So we've said over and over that we want to set resource requests and limits, right? But that's not the easiest thing to do, right? How many resources does my application use? How much memory does it use? How much CPU does it use?
That's easy. 4 gigs, everything across the board.
Definitely. Perfect.
Maybe not cheapest, but
I mean, if you're using Java, maybe. But so actually, I saw a recent video that said, well, my Mac has 64 gigs of memory, and it's got 8 cores or whatever. That's what my pod needs, right? Sure, definitely. But anyway, in all seriousness, how do we set our resource request limits? And we wrote Goldilocks with this idea in mind. So Goldilocks is a controller that runs in your cluster, and there's a few different components. But if we look at the Goldilocks namespace, there's a controller, and what it does is it watches for pods in your cluster. It looks up the top level controller for those pods. So whether that's a deployment or a stateful set or something else that creates pods, right? Because there's plenty of things out there that create pods that aren't in the standard set of controllers. And it creates a vertical pod autoscaler that targets the pods from that controller. So if we look in this cluster, we can see that we have a whole bunch of vertical pod autoscaler objects that have been created by Goldilocks. They're prefixed with the name. They've got some fancy labels and things. And they're all in a mode called, I call it recommendation mode. Here it just says off. But essentially what's happening is the vertical pod autoscaler controller, which is part of the autoscaler repository in Kubernetes, is watching all of these pods for how much resources they're consuming at any given time, and then providing essentially a recommendation for that. So it's got a recommendation built in, a recommendation engine built in. And so if we look at one of these objects in, say, our app namespace, maybe for the app server, we can see that we have a lower bound, a target, an uncapped target, and an upper bound. They all have various different meanings, but essentially it's an idea of how much resources my pods have been using over the last so much time. I also have this vertical pod autoscaler connected to Prometheus, so it's reading in some more historical data. And so we have all these vertical pod autoscaler objects, and so I can query these and see, okay, my app needs, roughly is using this much resources, but this is kind of hard to do. It's kind of hard to look at. And so Goldilocks also gives you a dashboard. So if we go over to the Goldilocks dashboard, we're going to see all of our namespaces listed. And again, I'm going to focus on our application namespace. And we're going to see various recommendations for our different apps. Important here to note, something to talk about is quality of service. So quality of service is a designation that Kubernetes gives a workload based on how its requests, CPU requests, and memory requests and limits are configured relative to each other. So guaranteed means we've set the requests and limits to exactly the same, and Kubernetes is going to attempt to guarantee that level of resources for the pod. We also have a burstable QoS, which means we're going to request so many resources, and then we're going to allow the pod to expand out to more resources. And so that's what our requests are lower than our limits here. And so we see for our app server, we're being suggested that we should lower our CPU requests, because over the last observed period, the app server here has only been using about 200 millicores, and we are currently set at 300 millicores. But our memory is recommended that we bump it up a little bit, and we're starting to bump up into the edges of that. And so we give you a nice little code block here. You can copy that, throw it straight into your application YAML, and reconfigure your app that way. It'll also tell you if it's not set. So this DB here has no CPU limit set at all, and some links and information at the bottom of the page if you want to read more about QoS. And we can list all the different namespaces here, and again, see them all across the cluster. I think we can even just see all the workloads in the entire cluster everywhere if we want.
So I have a question for you, Andy.
Yeah.
So let's say I'm new to Kubernetes, I've got my cluster, or even if I'm not new to Kubernetes and I want to figure out how to optimize these workloads, what would you recommend as the best way to get started? To just have very loose requests and limits and then let Goldilocks fine tune it from there?
Yeah, I've seen different strategies for that. In some cases, what I'll do is just deploy an application to a non-production cluster, and then not set any resource requests and limits. Run some load against it for a while, see what it consumes, and then look at the Goldilocks recommendation and use that. Another option is to run Goldilocks in production over time and let it watch your workloads over time to see what you're using and see if you need to tune that up or down. Obviously, if you're too low, you may see some performance issues early on. So maybe set them higher and then slowly ratchet them down over time. Those are kind of the two main strategies. The problem I see with running it in a non-production environment or in testing is that you have to be able to load test. And this is a problem with any tool that's going to give you resource requests and limits recommendations is if I can't generate meaningful load against my non-production application, then it's really nothing's going to be able to tell me how much CPU and memory I'm really going to need in the real world later down the road. So with this app, I'm fairly confident. I have a script coming in here, and it's literally just going and clicking the buttons. Now, obviously, this is a very simple app, but I have generated what I would consider meaningful load for this application. And so in my non-production environment here, I'm happy to say that these Goldilocks recommendations are probably somewhat realistic.
Awesome. And yeah, it seems like that's going to help with not just reliability, because having those requests and limits set allows Kubernetes to scale out as load increases, but also cost. If we are requesting the 4 gigabits that I did across the board, I'm spending who knows how many thousands of dollars or more every month.
Definitely. That's actually kind of an interesting story because, we originally wrote Goldilocks to be a resource recommendation tool for reliability, right? Because we were trying to get our customers to set these resource requests and limits everywhere and trying to make it easier for them to do that. And over time, it has definitely become as much a tool for folks to check out cost. And in the next probably 6 months or so, we're probably going to be looking at ways that we can integrate that better with Goldilocks and really focus on that cost use case in addition to the reliability use case of these settings.
That's exciting. Yeah, between the two of those, I feel like that covers such a good range of just, getting a cluster in a good shape. These two tools alone have so much to offer there.
Definitely. So one thing I'd like to note with Goldilocks and VPA in general that I think folks should be aware of if they're planning to use the tools is interaction with the horizontal pod autoscaler. So the vertical pod autoscaler, the reason we don't use it in the mode where it updates the actual resource requests and limits is that we generally recommend using horizontal pod autoscaling. So we prefer to run more replicas versus making our pods bigger. These are obviously a bit in contention with each other. So I'm constantly scaling out and trying to make them bigger and smaller. Like we can't optimize for all those things at once. So one thing to note using Goldilocks is that if you are using a horizontal pod autoscaler that's scaling on a CPU or memory metric, it's not going to give you realistic recommendations in Goldilocks because you're targeting a specific amount of CPU and a specific amount of memory usage. And so Goldilocks is probably going to tell you that you should be using that much all the time. If it's 50% of CPU is your HPA target, Goldilocks is going to tell you should set your CPU to 50% of whatever it is right now because the horizontal pod autoscaler is attempting to optimize for that. So if you are planning to use Goldilocks and the VPA and horizontal pod autoscaler, it's super important to remember that how those interact. And if you're trying to analyze usage over time and get better recommendations, you need to pin one of those things so that it can't automatically scale. So if you want to, set the horizontal pod autoscaler to a specific number of replicas, don't allow it to scale up, and then watch your resource recommendations over time and make the change and then re-enable the horizontal pod autoscaler, you can do that. But another upcoming feature, hopefully in Goldilocks, is to indicate where you're using a horizontal pod autoscaler. So if I click into one of these and I see that my CPU recommendation is low, I want to have some sort of indicator here that says, hey, this is using a horizontal pod autoscaler that's scaling on memory or CPU. This recommendation may not be accurate. All right.
Yeah, that's a great point. We've got a few more minutes. Do we have any other questions?
I don't see any in the chat.
Hi, Andy and Rachel. I'm back for my moderation duties. So I have a question for you, maybe a little bit Fairwind self-serving, but so if I really love these tools and I really wanted to use them, but I have so many clusters, and so I don't know how to easily apply this everywhere, what would I do?
That wasn't a leading question at all, Danielle.
No, it wasn't at all. You're welcome to all the people who are here.
So Fairwind's SaaS product, Fairwind's Insights, is specifically designed to ingest information from Polaris, Goldilocks, some of our other open source like Pluto, and other best of breed open source. So like Trivy, we incorporate with as well, and a few others. And it does that across multiple clusters, and provides all that information into a single dashboard where you can look at all these different things all at once. So, and it includes even enhanced recommendations over what Goldilocks can give you for your workload efficiency and your cost settings and things too.
Awesome. Thanks for the comment from CT. Looks like you've got some fans out there. And thanks for all the comments. Oh, Andy, thank you. Johanata, what a cool name. Refik, thank you so much for all the engagement. Hugo, been engaging the whole time. Really, really cool. Any other questions? That we have like 4 more minutes before we are supposed to do our next networking break. Anyone else? Anyone else?
Nothing for me. Thanks for having us. It's been a pleasure. Thanks for putting this all on. Dave, Danielle, and everybody else. You all make my life easy, and I super appreciate that.
Nice. It's on record.
Thank you, everybody. And yeah, if anybody has any Kubernetes issues that they just can't figure out, feel free to reach out to us at Fairwinds. We love those hard problems. So
yeah, Rachel, where do people find you? Do you have a Slack channel? Do you have a Discord? Are you on? Do you have a forum? Where do people post their questions?
That's a good question, Danielle. Where do we do that?
It was Lisa. It wasn't a cute question.
I think that was pointing Danielle into. So we do have a Fairwinds Slack community. You can join it. If you do join it, you'll see that we have a number of people in our Goldilocks channel talking about the project. We had somebody writing a blog post about it today, so it's really cool. Join that Slack community.